Good afternoon, everyone, and thank you for joining in on our webinar this afternoon for Unpacking the new VCE Mathematics Study Design with Cambridge Senior Maths. My name is Kim Keenan. I'm the National Webinar Specialist for Cambridge University Press. Before I make a start, in the spirit of reconciliation, Cambridge University Press and Assessment acknowledges the traditional custodians of country throughout Australia and their connections to land, sea, and community. We pay our respect to their elders past and present, and extend that respect to all Aboriginal and Torres Strait Islander peoples today. Please know this webinar is being recorded and will be distributed by email to all those registered following this event. You'll also receive a link where you have the opportunity to give feedback on your experience this evening, and of course, choose your free book as well. You can ask any questions in the Q&A box that you will see on your screen, and we'll constantly be monitoring that throughout the webinar. If you could also add your email address into any question that you might have, that would be great. Just in case we can't get to everyone all at once, we can at least get back to you when the opportunity does arise. If you do prefer to wait until the end, we are having a full Q&A session with all of the authors as well as the Cambridge team. But it's important to note that there's a large number of people in our session this evening, so as much information that you can add into that chat box would be great. I'll be detailing publication dates as well and page proof dates at the end of the webinar. So stay tuned for that rather than adding that as a question in the chat box. Before we begin, I'd like to introduce you to our authors who'll be speaking this evening. Peter Jones. Peter is a Professor Emeritus and former head of the School of Mathematical Sciences at Swinburne University of Technology. He's been an active supporter of school mathematics over many years and helped pioneer the introduction of graphics calculators into Victorian schools. Peter is a highly experienced writer of mathematical content. His area of expertise is applied statistics. Rose Humberstone. Rose is an experienced teacher of VCE mathematics with degrees from the University of Melbourne in Science and Commerce, a PhD in economics, and a master's in education. She's currently a head of house at Scotch College. Rose has held various curriculum leadership positions in her career, as well as working as VCE examination assessor. Peter Karakousis. Peter has degrees in science and education from Monash University. He's an experienced teacher of senior VCE maths, an assessor for the VCE examinations, and a workshop presenter for students and teachers at Australian Catholic University. Peter has served as a board member for the Mathematical Association of Victoria and is currently a teacher of maths at Scotch College. Let me also introduce you to our Victorian sales team. So we have Emma Kapler, she's the state manager for Victoria. We have Carolyn, who looks after the north side, and Kim, who's east and southeastern suburbs, and Marcus, of course, who looks after the west. So without further ado, please let me introduce our first speaker of the ranks, Peter Jones. Welcome, Peter.
Thank you, Kim. Let me just move on, and sorry about that all. Okay, well, I'm Peter Jones. I will have met some of you in the past, but not all. My role in this presentation is to give you an overview of what's changed and what hasn't changed in the new general maths study. Plus, I'll give you a brief introduction to Leslie matrices. It'll all be basically brief because there's plenty of stuff, or more than enough stuff to talk about. Right, let's start with General Maths 3 and 4, which is now the old further. The big difference, a big change that's happened there is it's now fully prescribed, and the topics that all students will do are data analysis, recursion, financial modelling, matrices, networks, and decision maths. And I'm sure you all know that by now. But one of the good things probably with 3 and 4 is, apart from some relatively minor modifications to existing content, the only really significant new bit of content is Leslie matrices, and that becomes part of the transition matrix topic. And I'm going to return to that later. Right, moving then on to General Maths 1 and 2. That's a more difficult thing to talk about. There's lots of changes in one sense. First of all, it's now fully prescribed. So students will have to cover material from the 5 study areas of study: data analysis, algebra, functions, discrete mathematics, and spatial measurement. That is prescribed in the study design. I won't go into the details there. The information that I have on the screen, you'll find exactly that sort of thing in the study design. Right, looking at some, G1 and 2, there have been some modifications. There's been some additions, and some modifications and some deletions, mainly little additions. The additions that you might want to be aware of is that there's now in univariate, there's a brief introduction to the 68% rule. In matrices, there's been included a brief introduction to transition matrices. One of the things that's happened, there's been a lumping together of the old general maths, consumer maths topics, along with a recursive introduction to sequences. That's a big, big lump. Something that many of you wouldn't have heard of in the graphs and networks, the concept of greedy algorithms is introduced. Finally, the topic of variation, which had relatively little relevance to previous year 12 stuff, has been reduced to a short basic introduction, essentially to data transformation and an introduction to logs. They're all pluses, all stuff that's been added in, but all the linear programming is gone, and that's what's not taught in year 12, and that's gone for the pillars, making some space, but not a lot. Okay, let's moving ahead. We have a tight thing. What I'm going to do now is something that I think not many of you will know a lot about, and that's the Leslie matrix. And that's something, if you're teaching year 12, will be included in new year 12. If you taught further maths before, you should be familiar with a T matrix, a transition matrix. The Leslie matrix is also a transition matrix, but it's one that's been specifically designed to model the change in the age distribution of an animal population over time, which takes into account both births and deaths. This is relatively recent mathematics, or is for me anyhow. It was developed in the mid-1940s. Some of us were around then. So it's a powerful technique which doesn't require a lot more than the stuff you've done in transmission matrices to do the sums, if you like. But there is an issue of interpreting. The population, the sort of population we're talking about, animal populations, I've got a sample of one here. This is hypothetical, but it's not unrealistic. We've got a seal population with 3 age groups: pups, young adults, mature adults. We've got 3 age groups: 0 to 3 years, 3 to 6 years, 6 to 9 years. And then one of the assumptions made, but it's not necessary to do, a lot we're assuming that the lifespans of these seals is 9 years. So once they get to that end of the age group, they just disappear. The age distribution, which is what we're going to be focusing on, is over on the right-hand side, the last 2 columns. You've got a list of ages, and you've got a list of number of seals in each of those age groups. So it's a bit like in statistics when we have a histogram of age groups. So what we're going to see is basically, let me go on there. What does a Leslie matrix look like? It's a raw Leslie matrix. If you're familiar with transition matrices that you've met before, the T matrix, as I've called it, the columns don't add up to 1. You also get in this matrix numbers that are greater than 1. And what I need to do, and what I think is useful for you to know before you start teaching this topic, is where these various things come from. So that's a very crowded screen. And I think we can get there by focusing mainly on what's in the right-hand column. The details are in the left-hand column. The T matrix, to know the Leslie matrix, to understand what's in it, we need to know what are the basic components that set it up. First of all, we have age groups. In our particular problem we're dealing, or situation we're dealing with, there are 3 age groups, and we're going to be looking at the transitions between these three age groups. So the transition matrix, the Leslie matrix, will be a 3 by 3 matrix. You can see it down the bottom of the page if you want. The other thing, because we're dealing with age ranges of 0 to 3, they're hunks of 3 years each, the time period we're looking at is not 1 year, it's 3 years. We're looking at what happens every 3 years. So that's a time period is something to take notice there. There are models in which you might have it that change every year. There could be a human population, so here 1-year-olds, 2-year-olds, 3-year-olds, and so on. What I've got there next, which is just like the transition diagrams you've seen with the normal transition matrix you've been dealing with if you've taught further before. It's much the same thing, and it, I suppose, demonstrates visually what the transitions are in this particular problem. So if we can see here, we've got, I'll go down and get my pointer on. We see we've got 3 age groups, 1, 2, and 3. That's the 0 to 3-year-olds, 3 to 6-year-olds, the 6 to 9-year-olds. You've got some red arrows. The red arrows represent birth rates. So we can see there's a red arrow going between age group 2 and age group 1. They're the pups and they're the young adults. The 2.3 tells us that the average number of pups produced by a female in age group 2, a 3 to 6-year-old female, is 2.3. When we look at this other red arrow we've got here, that's for the older seals. There is a fertility rate, or the birth rate. The number of tells us that for those particular seals, during the time they're in age group 3, well, they're aged between 6 and 9 years, on average they produce 0.4 pups during that period. So that covers the birth. So we've covered the births. I said before that we're dealing with deaths and births and deaths. The deaths we cover by looking at survival rates. And the survival rate tells you the proportion of females in each age group surviving to move on to the next age group. We only deal, by the way, in this model with females because we can't have the males mixed up in it. It's not a big limitation, but they were only dealing with females. So if we look at that, we've got an arrow, a blue arrow, going from age group 1 to age group 2. That 0.6 tells us that 60% of the pups, that is those seals, the female seals in the lower stage group, survive long enough to go into the second age group. And then we have another arrow, a blue arrow, that's indicating a survival rate. The survival rate's the proportion of seals that survive this one, a 0.3, or 30% of the young adults survive the age group of 3 to 6 and move on into age group 3. And basically, you can have this information given to you, by the way, in a table, but I think it's looking at from the transition matrix point of, from the transition diagram point of view, is much more informative. So when we put all those things together, here's our Leslie matrix that we can use to analyse these situations. It's a 1, 2, 3 by 3 matrix. The transitions go from age group 1, 2, and 3 to the age group 1, 2, and 3 every 3 years. So if we look in this particular matrix, it's got a different format than the transition matrices you used to. The top row represents birth rates or fertility rates. So you can see in here, if we go across, there's the pups are infertile, so there's no births coming from, emanating from the group 1. From group 2, the females in group 2, over that time period of 3 years, they produce on average 2.3 pups per time period. And then we have for the older age group, we have the 0.4 there, which means it shouldn't be yes, 0.4. So the female seals in this age group produce on average 0.4 pups for the 3-year period that they're in, 3-year period that they're there. Now, the top line in the Leslie matrix always represents the birth rates. Then the following rows, and down here, we've only got 3 groups, there's only 2 more rows in the matrix, represent the survival rates. So you can see from here, this is a from to the 0.6, that says that 60% of the pups, or those in group 1, survive into group 2. And here we can see the 0.3, that tells us that 30% of the young adults survive to go into the older or the mature adult section. And that's the whole lot. It's not going to be up to students to put together these matrices, but I think it's not a bad idea to build it up so they understand what it is. A key difference between doing the current transition matrices and this particular topic is one of interpretation. They have a different interpretation, and probably a slightly more complex interpretation. So, all right, let's put it all together. We can represent the age distribution of this particular species by a 3x1 column matrix. And the SN, capital SN, which we're used to in transition matrices, this is the age distribution after n time periods. Then if we want to track the change in the age distribution, we can use the familiar transition matrix recurrence relation that we've got. We've got a starting value S0, and we've got a recursion relation linking step n plus 1 to step n. It's the same exactly as you would have, the same form that you have exactly with a T matrix. So to start off, let's assume that we have 400 animals in each of these 3 age groups. It's quite arbitrary. So our starting point, we've got a population of seals with 400 in each of the 3 age groups. We can then go through the process step by step of calculating from a given, from our starting point, our S0, our 400 in each thing, we can work out how many after one step, after one 3-year time period, how many are in that second age group. And that's done by using that common relationship, S1 equals LS0. And as you can see here, there's an increase here, a decrease there, and a decrease there. So on, we can step our way through the whole problem, or the thing, and find S2, S2, which is actually a matrix representation of the distribution, the age distribution of these seals. I'm not going to go through all that too long, but what I've got here is a summary of what we find. It looks a bit different than we often do. If you look here, that's basically your S0 matrix. That's put that in. That's S0. That's the distribution of seals according to age at the very start. And we move through this. This here is after this is a distribution, the age distribution of the seals after 5 time periods. So it's actually 15 years. The other thing that we don't worry about too much with the normal transition matrices is because the normal transition matrix population, the total size, the total number of elements within that matrix remain constant. We don't worry about the change in the overall population size because it never does. But here, that's one of the key issues. So we can see here, this particular column shows the population, the size of the population for each time period. So we start off with 400 in each group, it's 1,200. And as we go along, we can see here it's increased in total after 15 years to 2,956. I've got that right, haven't I? Yeah. At the moment, if you look at some of these, some of them go up and down and eventually go up. But to have a look at what happens in the longer term, I've actually printed out here the state matrix, or the age distribution of the seals at after 14 time periods, 42 years, and here after 15 periods. And you see all of them have gone up, and some more. It's the younger group has increased most rapidly, and less as you go on. You also can see that it's starting to settle down, where in the earlier stages there was an up and down movement. It's settled down to the general growth. We could see this more by putting more states in. So the, excuse me, the going from 14 to 15, we find all of the various subgroups, or the various age groups, the numbers are increasing as we go along. So in a sense, and this is a very qualitative and very limited interpretation, but we've got a population that is increasing in time for all age groups. Now, there's lots of options you can have. It could be decreasing in time for all age groups. It could have some age groups increasing and decreasing. And that's one of the things that students will need to be able to work out by following through the change in the state matrix over a period of time. It's the sort of thing.
Excuse me, Peter.
Yeah.
Peter, we're going to need to wrap up shortly. So
I'm right on wrapping up time.
Wonderful, thank you.
Good. Okay, so that's just I'm finished. But before I go, something here to say. Hold on. If you have any questions, we're going to have a Q&A session later on, and then it's my pleasure to introduce Rose, who's one of our new authors, who's going to talk about basically the new structure we're using in our 1 and 2 book. Okay, thank you, Rose.
Hi, I'm Rose Humberstone. I'm a senior school maths teacher teaching from year 7 to 12, and also one of the new authors on Cambridge's General Mathematics VCE textbook series. Today, I'm going to be talking to you about the new pedagogical structure of General Mathematics, Units 1 and 2. So the approach that we took in redesigning the structure of the textbook was first of all to think about who's using the textbook. That is, our teachers and students. We recognise there are lots of new maths teachers entering the profession, and that means a lot of new maths teachers will be teaching general maths for the first time in the coming years. We also realise that there is a wide range of abilities in general mathematics. We have very able students who are capable of doing both maths methods and specialist maths, who have decided to take general maths instead, or as well. We also have students who have struggled through year 7 to 10 maths, who are ambitious and decided to take on general maths. Thus, the range of students undertaking and using our textbooks is quite broad. In addition to catering to the new teachers, existing teachers, and the wide range of students, we also wanted our books to be useful both in the classroom context and also to provide additional resources for out of the classroom, whether that be homework, so more questions, or additional resources. So the general structure of the textbook is based on chapters for each topic and then sections within those chapters. Each section is designed for a single lesson. Now, in different schools, a single lesson has a different length, ranging anywhere from 40 minutes through to over an hour. So we've tried to come up with something that is a little bit more flexible, but could be done in those shorter 40-minute, 45-minute lesson situations, but also something that has enough in it and enough questions so that your students or children can consolidate their learning. Each section begins with a clear list of learning intentions for that section. So here, for example, we have writing recurrence relations in symbolic form, and the 2 learning intentions are to be able to number and name terms in a sequence, and also to be able to generate a sequence from the recurrence relation. This is really important because it's then clear to the students what they should be able to do by the end of the lesson. And it's also helpful to the teacher to be able to quickly see these are the key skills and learning intentions of this section. Another thing that we've worked hard on is to redevelop our examples. So our examples were rewritten to reflect the study design and the Year 12 exams. Now, depending on the topic, some of the sections required more rewriting than others, but we've tried to implement the same strategy in Year 11 by matching to where we want the students to be for their Year 12 exams into Year 11, but at an easier level. So our examples have been rewritten. Additionally, there are videos of each example available online. The newest initiative, though, is our use of paired examples or example problem pairs. In this case, we've called them Now Try This. The way it works is that for every example in the textbook, which has a fully written solution underneath, there is a very similar question called a Now Try This immediately afterwards. The Now Try This has a question and a reference to the example that it refers to. It's then followed by some hints to help the student. These could be useful in a classroom context where the teacher goes through the example and then the students can immediately have a go themselves without the answer and solution right there in front of them. They have hints if they need, which some students will and others won't, and the answers for these are also in the back of the book. The educational evidence on this method has shown that students perform better when they have example problem pairs rather than the more traditional method of presenting examples and then after the explicit period of teaching, students then going off and doing some work. This is a good way of consolidating, especially among your weaker students in your general maths classes. Additionally, each section concludes with a clear summary of the section. Each chapter also has a glossary where key terms are defined. So for example, here we've got a section summary with a basic recurrence relation and also a rule for directly calculating term Tn in the sequence. Probably one of the things that you'll notice first when you look at the book is that the number of questions in the exercises increased substantially. In some cases, the old textbook had very few questions. And so what we've done is we've restructured to make sure that each section has a suitable number of questions for each lesson. But we've also broken up the questions into 3 main sections. So the number of questions allows for questions in a lesson, plus some for homework consolidation. And then to allow for the diversity in student ability, we have 3 different types of questions. We have building understanding, which are aimed at weaker students, a developing understanding aimed at the average student, and testing understanding, which are aimed at our more advanced students. As a teacher, I would be getting my weaker students to start on the building understanding questions. This is a great opportunity for them to consolidate what they've heard and also helps them to get going, which is something I find those weaker students find particularly challenging. I would then get those students to continue on with the developing understanding questions. For an average student, I would get them to start with the developing understanding questions, and I would get them just to do those questions. Whereas for my more advanced students, I would get them to start with developing understanding questions so that they can build and consolidate their skills. And then I would also get them to do some testing understanding questions to really extend and test whether they deeply understand the concepts being taught. So here's a little example of the building understanding, developing understanding, and testing understanding questions. So you can see that our building understanding questions are very simple. State the starting value. Rewrite the sequence and write the name of each term below each term of the sequence. They're quite basic, but they're questions that those weaker students can just get going on. Whereas in question 4, which is our first developing understanding question, this relates to our example. So we've got those links in place and students can just get going straight away on those if they're capable. And then lastly, our testing understanding questions. They'll often approach the same skill or concept, but from a different angle. So here we have our occurrence relation. And then our first question is to state the term name for the term that has a value of 23. So students need to go backwards essentially. They need to work out what the values are, and then what the term name for those terms will be. Lastly, in our chapter review, we have our key ideas and chapter summary, or our glossary, like we've always had. But then we've introduced a new thing called a skills checklist. The skills checklist, which can also be downloaded from the interactive textbook and printed out, can be useful for students as they revise the section and chapter. So we can see that there's a list of key skills, and these key skills match up with the learning intentions from each section throughout the textbook. So we can see that the first one, I can identify the behavior sequence. It corresponds to section 3A. And then there's a question for students to see, well, can I do that skill? All of the answers for the skills checklist are also in the back of the textbook, so students can see if they're getting it right. Of course, if they're getting it wrong, they can look at the reference 3A and go back and have a look at the examples and try some additional questions. Following this, as normal, we have our multiple choice, short answer and extended response questions, which are designed to help consolidate and test and develop students' understanding further. Well, that's it from me. Thank you.
Hi, I'm Peter Karakoussis. I'm one of the new authors of the General Maths textbook. And as a teacher of General Maths, I'm excited to share with you some of the new features we've included in the latest edition of the books. In particular, we've ensured that there's a greater focus on how best to support teachers and help students prepare for their end-of-year exams. Here's a list of some of the components of the new books I'd like to highlight in our session today. For example, some of the new features at the beginning of each exercise have got a list of learning intentions. And these are to help guide you in terms of what key knowledge and skills from the new study design each exercise will be covering. At the conclusion of every exercise, there will now be exam style questions, where the authors have taken the time to write new questions that replicate the style of the VCAR exams, such as the structure, how the information is presented, and the language frequently used to give our students an insight into the standard that they can expect at the end of the year. At the end of a chapter, we have added a skills checklist to help students identify key knowledge and skills they should have mastered, or perhaps help expose some gaps in their knowledge they must focus their revision on. With the first edition of the book, each of the topics had an extra chapter dedicated to reviewing the entire topic. In the latest edition, we've added a new chapter at the end of the book that provides more questions that review all 4 topics of the entire course. Again, new exam style questions. Of course, with all these new additions, it's also important to highlight our regular favourites that aren't going anywhere, such as the step-by-step examples, the glossary at the end of the chapter, and the exam style questions. However, it is good to know that there will be more questions for each of the exercises, the online quick quizzes, and each of the chapter tests will be updated. A new feature is the exam generator, where this is an online component that is essentially a past VCAR question bank, where you log in with your teacher suite, and past VCAR exams have been sorted by topic and tagged with the percentage success rate. Teachers will be able to select which questions they like, and a practice exam will be generated, ready for print and or online distribution. There will be a cover page indicating how long the test will take, depending on how many questions the teacher selects. And in terms of the online practice tests, auto marking will be available, as well as reporting. I know that the Cambridge sales and marketing teams will be coming to schools in term 3 to help provide demonstrations for interested teachers. Thank you.
So thank you everyone for waiting. We can also send a big thank you out to Peter and Rose and Peter Karakoussis as well. Thank you so much for your sessions. We now have a Q&A session with everyone, but we're welcoming a few additions. So Michael Evans, if you want to give a little wave and say hello, and Kay Lipson as well has arrived. David Main too is here, and Barbara Tullock as well has arrived as well. So good. And Scott Halligan, who is our very own education publisher from Cambridge. So welcome everyone. Now we are going to go through some of the questions that have come through in the system and get those questions responded to from the group. So I will get started on the first one here. Will we be getting a lesson on each new concept, or is this an example of one of the changes? So I think that this is talking about Peter's first presentation, and this is from Emma.
Sorry, what was the question again? I didn't. Who?
The question is, will we be getting a lesson on each new concept, or is this an example of one of the changes?
What's that relate to? I don't know. Will we give a lesson on each concept? Is that maybe that's in Rose's thing?
This one came in a bit earlier, so I was thinking it must have come from yours, but that's okay. We can move on to another question anyway.
Yeah, I'd like to answer it. Maybe the person could email me.
Yeah, right. Yes, agreed. So we've got another one here. Will we be required to increase complexity of the matrix relation, have a positive C like in transition matrices?
I'm having, your voice is a little bit funny. Can you say it again? Sorry. Sorry, Kim, can you ask that question again slowly?
Sure. Will we be required to increase complexity of the matrix relation, have a positive C like in transition matrices?
The answer to that question is the reason we have a positive C, we have a more complex relation, is that the transition matrices will only deal with modelling situation with a constant size population. The Leslie matrix is designed to model exactly those situations. So you won't need to add a C or anything like that. And now it's not included in, as far as I can tell from the study design. I think the study design just says the T matrix plus a constant is that particular thing you're talking about. But
okay.
I hope that makes sense.
Yeah. Here's another one. Does this all need to happen recursively, or can powers be used? This is from Chris.
You can, yes, it's. I actually took out some slides because we had limited time. You've got the relationship. You've got your step-by-step relationship for the Leslie matrix, and it's exactly the same as you have for the T matrix. You have a power relationship too. So you've got a relationship that says that Sn equals L to the power n S0. So you do have that.
Great, thank you. So one here from Angela too, and I can answer this one. Is it possible to get a copy of Peter's PowerPoint? Yes, it is. I've got your email address here, Angela, so we will send that out to you. And everyone actually will receive a copy of the whole presentation from an email that you receive after the webinar, where you can give some feedback as well. So know that everything will be inside of that as well. But if you do want the PowerPoint presentation specifically, we can also send you that. The next one I have here is from Craig. Do you have any help, sample tasks, etc., for the investigation tasks that we have to do next year?
Yes, in the Year 11 book, we'll have tasks included for each of the topics.
Excellent, great news. Emma, can I hand over to you so that you can read some of those live chats questions?
Sorry about that. Yes, of course. Question from Naomi. This is for you, Peter. Do Leslie matrices ever end up in a steady state matrix?
That's a very complex question. They do have a sort of steady state. It's not like you have with the T matrix, which has the a fixed number in each of the age groups if you had one. This is in the Leslie matrix, it has in effect a close to, it's really a limiting state, it's a bit more complex mathematically, but it's in the rate of increase, which is a steady state. Eventually, if it's a growth, if it happens to be a growth model, or it happens to be a decaying model, in certain circumstances, it'll settle down with a constant, either growth rate, it'll be exponential growth rate or increase, or growth rate or decay rate. So it's the change that settles down to a steady value, not the absolute numbers, because you can't have a steady state if you've got an increasing or decreasing population. But what it is, it's a rate of that change in the population that follows a steady or limiting state.
Thank you.
Getting ahead of me. That's right.
A question from Chris. Now, further to the steady state question, do all Leslie calculation need to happen recursively?
I think the answer is yes. It's a transition matrix.
Peter, I think he means, you know, with transitions where we can do, say, t to the power of 2, t to the power of 3.
Oh, you mean not step by step?
Correct.
Yeah, oh, no, yes, you can either do step by step, or you can do it to the power of the number of transitions. Okay. That was one of my slides, but it dipped out when we had time.
And it will be included in the books.
Yes.
Yeah.
A question from Craig. Sorry, can you hear me okay? Yep, okay, good, sorry. Do you guys offer any help with the investigation tasks that we now have to do?
Well, I'll just say that I'll throw to perhaps Rose in a second, but certainly for the units 1 and 2 book, where the investigations are part of the study design, there are practice investigations in all of the revision chapters, and there'll be more online in the teacher resource as well, so that students won't have seen those. I'll pass on to Rose, who can explain a little bit more if there's anything to add to that.
You know, I don't think there's a lot more to add. Obviously, it's something new that's coming into year 11 next year. So we'll provide samples, as Scott said, both for teachers to use that will be unseen by students, that you can adapt then to suit your school's context. So hopefully that will be useful. Obviously, it's a new thing, and so we'll see how it works out. But obviously, if there's any feedback, we'd be interested in having it too.
Thank you. Question from Jessie. Is there any of these features going into the methods textbooks? It doesn't seem so on the samples from the website.
I'll throw over to Michael in relation to that one.
Okay.
Yep.
The features, in actual fact, the investigations are a feature in every revision chapter, for instance, that they're there, and there'll be online resources too to cover that. So yes, features are shared by both, but not exactly the same. There's a different type of book, but we will actually give full support to investigations, probably about 5 in each set of revision exercises, just to start off with. And that's the same with specialist mathematics too.
What year do the VCAR exam questions in the generator go back to? Scott,
So
maybe?
it differs per subject in terms of our agreement with VCEA. I can't off the top of my head remember exactly how far. I think it's about at least 7 years for further, and a little bit longer for further in general, a little bit longer for methods and specialist. But certainly when we can offer more in terms of workshops and have samples and a demo, working demo in term 3, we'll also give those kinds of details as well.
Well, it's
But
great to know
there'll be
7
plenty
years.
in the bank. Sorry, Peter, go on.
Yeah. They'll include all of the current study design, all of the questions there from further when it started in 2016. So that'll be great.
That's right. Exactly. That's right. Yeah.
A question from Ian. It's quite a big one, so I'm going to cut it down a bit. He said, I assume from what has been said, the sequences section of the general 1 and 2 text has been rewritten. Am I correct?
Can I answer? Well,
Let's
I'll
go
answer
to
that,
Rose on
and
that
then
one.
Rose can answer as well. The answer is yes. And one of the issues that came up in the previous curriculum, the way the study design suggested sequences should be introduced was non-recursively. There was some in it, but and of course in year 2 we had a recursive issue, and there's been an issue of what you call the starting term, T0 or T1. Now the recursive approach is used in both the year 11 and the year 12, and you can always sensibly make the first term T0. Or Rose, you have a go.
Yeah, so I guess historically, when the previous or the current Cambridge series came out, it was based on the reading of the study design. And as we've seen VCAR exams unfold, that's given us an indication of what was actually expected. And so working back, year 12 was, I guess, a bit closer to the exam, but the year 11 book we felt wasn't preparing students adequately and going in that right direction. So that chapter is essentially a complete rewrite, and it should be sequenced. Hopefully you'll notice sequenced nicely to lead in from year 11 into year 12, following that recursive approach.
Thank you. Justin has a question on the exam generator. Does it keep track of the questions you've used on previous tasks? Assist minimizing reusing questions multiple times.
Yeah, that is in development. That's certainly something we are working on as part of the functionality of the exam generator.
Thank you. From Valu, how would you incorporate media into the physical textbook? Is there such media in the interactive textbook version? As there are such media in the interactive textbook version, sorry. I'm not sure about that.
Media, I mean, we're asking sort of rhetorical questions, but it might be possible for the person who asked that question to clarify. Media as in digital assets, interactive assets or something like that, or do we mean media as in the media if we're talking about, you know, data analysis or representations of data in the media? I'm not 100% sure.
We might ask Valu if they can, perhaps.
Yeah,
I think potentially maybe they're asking about the videos that go along with the textbook examples.
Well, okay. If it is about that, there'll be worked example videos for every worked example in, not just for general, but for all the books in the series.
Yep. A question from Libby. In the study design for recursion and financial modelling, the limit of n less than or equal to 5 has been removed. What is the significance of this?
I can answer that one perfectly. It's just sort of no longer relevant. It was there to stop people, to encourage people to make decision about whether they would use something like a financial solver or to do it step by step recursively on their calculator. And it's 5 was just a thing to say, don't do too many. And so it's really now a judgment. And some problems you can do either way, and it's up to the students how they choose it. But often I think people are finding that doing it step by step, even if it's more than 5 steps, is a quicker way of doing it and a more visually acceptable way of doing it. So that's gone out because it really was unnecessary.
Thank you. With a few people have again asked for a copy of Peter's PowerPoint, so we'll definitely make sure we get his PowerPoint out to everyone. Now, a question here. How many hours would you expect to spend on Leslie matrices?
I'm not actually a classroom teacher, so I couldn't tell. But I expect it's a natural extension of the ordinary transition matrix. the advantage you have when you're teaching it is all the mechanics are exactly the same. And as in that particular topic in the exam, the vast majority of questions are about the mechanics of the process. I don't think it'll have to be too long, but the big issue is the students will, it's a different interpretation than the normal transition matrix, and that's where the more challenging questions I expect will be. But there's a lot of mechanics as well.
I can foresee it being between 1 or 3 class lessons, if you want to talk like that in terms of hours. I think it just depends on the class, because, you know, there are some years you get a really strong class coming in and you might get that class that picks up the concept within that first lesson, and then they just go off running into the exam style questions we've included in the book. But I can foresee, say, in a different year, you'll have the group of students, they might need, say, 2 lessons to wrap their head around it and really master those skills, potentially a 3rd lesson as well.
Can I just add another thing now? In year 11, there's an introduction to transition matrices, not including Leslie matrices. So with the students, once they've been through that, they should even be better at the mechanics.
Well, we've probably got time for a few more questions, then we're going to have to wrap it up. Now, Jessie actually has asked when we can expect to get access to the textbook, digital or physical. Kim's going to actually talk about that in the next few slides. So hang that, please, Jessie. Loads of people still asking for a copy of Peter's PowerPoint. Will the Unit 1 and 2 investigations contain open questions as is expected in Units 3 and 4?
Peter?
I think this one's best asked by either Scott or Rose, I think, for the mechanics of the investigations.
What was the detail of the question again about the difference?
It's will the Units 1 and 2 investigations contain open questions as is expected in Units 3 and 4?
I'll have a go at this, and then perhaps Rose can expand on it. But I think that they may be slightly separate things. The investigations in Units 1 and 2 are not found in 3 and 4. There are obviously different assessment types in 3 and 4, but we haven't prepared the investigations specifically to lead to an equivalent more complex or open-ended version in 3 and 4. But I'll throw perhaps to Rose to expand on that.
Yeah, I think what Scott is saying is right. The other thing I'd add is it probably depends a little bit on the topic as well. So some topics, it might be a little more open-ended. We are very aware that, especially in Units 1 and 2 of General Maths, the cohort does tend to be a bit weaker than what we get in General Maths 3-4, simply because there are students who perhaps giving methods 1-2 a go and then switch. And so the cohorts are slightly different. And so in General 1-2, anticipating a slightly weaker cohort, I would envisage it'll be less open-ended than what one might expect with a stronger cohort. Those students often just need a little bit more hand-holding and direction. But as I said, depending on the topic, the degree of openness might also vary.
Okay, thank you, Rose. Question from Sam. What is happening to the chapters on discontinued modules such as linear programming and measurement and geometry? Are they being deleted entirely, or will they be available online as an appendix?
Well, I can answer that in part. The linear program is gone totally. The geometry is still in the book because it's part of the course still in year 11.
Yeah, and in general, we don't tend to keep material that is no longer in the text design. We sometimes do more for methods and specialists have appendices like that. And sometimes, as we found recently, some of that material just returns into the study design years later. We can certainly, if someone would like that material, PDFs of that material, something like that, they can certainly get in touch and we can provide that. But there's no specific plans to retain material that is no longer in the study design.
Thank you. Maybe this will be the last question. Has networks changed much in the new curriculum?
Probably me. And Peter can maybe come on this. The year 12 one has not changed a lot. There may be changes in the way things are done, but not in terms of absolute content. The year 11 is slightly different, and there are more algorithms involved in year 11 than there were in the past. Peter, you might like to comment because you had something to do with that.
Yeah, sure. So for those that went through Peter's presentation earlier, when the mention of greedy algorithms was highlighted, that's really just an umbrella term we use for all the a couple of different algorithms, some that were already used in the course, in the 1, 2, and 3, 4 course, Prim's algorithm. However, there will be a new algorithm introduced in the 1, 2 course as well that also is used to identify and look for the minimum spanning tree. In the 3, 4 course, as Peter said, there are no changes in the study design, but what we have made sure to do is in the 3, 4 book is introduce maybe some new methods that we can suggest and as an alternative to what's been given in the past. For example, the shortest path problem, we still go through Dijkstra's algorithm and inspection, and we also go through a new graphical method as well.
Okay, thanks very much for your questions, everyone. And over to you now, Kim.
Lovely. Thank you, everyone. Well, I just wanted to run through a few slides so that we can really have a good idea and indication about timelines on when to expect everything to come through as well. And so page proofs will be ready for units 1 and 2 in early June, units 3 and 4 in July, and the publication dates will be August for units 1 and 2, and units 3 and 4 in November, which is really great. Price points, so textbook print and digital, $89.95, the digital code, $69.95, and of course the teacher suite is $149.95. I've also put a few faces that we've already met. So all of your consultants, please reach out to them with any questions that you might have, certainly pertaining to publication dates, digital codes, pricing points, and certainly being able to come out and do PD in the schools or via Zoom or Teams if that's your preference. But thank you all so much for coming along this evening. And please, as a reminder, know that you will be receiving an email following this webinar where you can give your feedback on the webinar itself, but also it's the opportunity for you to choose the free book that you would like to have. So make sure that you jump on board and make use of being able to get a free textbook, but it's also a good way for you to reach out to us, and then we know when you're wanting to get some more information as well, and we can get the relevant consultant to get in touch with you. So please join me in thanking all the authors, and thank you all for coming along this evening, and good evening to everyone.